Today we're going to find the areas of rectangles and parallelograms. If you remember before talking about quadrilaterals, we had trapezoids and then we had parallelograms. And from parallelograms, all these down below, rectangles, squares, rhombuses, are basically parallelograms, different types of parallelograms. So a rectangle is a type of parallelogram. And the area of a parallelogram is the product of any base length, B, and the corresponding height, H. So we have a base and a height, base and a height, base and a height. So the area is base times the height. For our sentence below, it says it is the area, they didn't leave much room there, the area of a figure is the number of square unit it encloses. The number of units it encloses. So basically the inside is considered the area. Now let's go over the definition of an altitude. An altitude is a line segment perpendicular, P-E-R-P-E-N-D-I-C-U-L-A-R, perpendicular. It's a line segment perpendicular to the base of the shape. The base of the shape. It is the height. It is the height of the shape. So an altitude is a line segment perpendicular to the base of the shape. It is the height of the shape. And if you notice right here in these diagrams, you see they have the height right there. Notice how it is perpendicular. It makes a right angle, 90 degrees. Here again, perpendicular. This is the height. The height is not always going up and down. And again over here, sometimes it's not even inside the shape. But that's referred to as the altitude, and the altitude is basically the height. Okay, it says finding the area of the rectangle, and here it is here. Notice the units are different. This is 4 meters, and this is 150 centimeters. You see that? Centimeters and meters. So we have to convert one of them. We have to either make this into centimeters or this into meters. And notice in step 1, they say change units so they're the same. 150 centimeters equals how much meters? So we need to change this to meters. Okay, I just made a crude drawing over the side here. But let's just say that this is the same thing as almost like a yardstick, but instead it's a meter, 1 meter. So from here to there is 1 meter. All right. Now down here, turns out that 1 meter is 100 centimeters. It takes 100 centimeters to make 1 meter. Okay, it takes 100 of them. So if that's the case, if it takes 100 of them to make 1 meter, how much is 150 of these? How many meters is 150 centimeters? We know 100 is one of these. How much is 150? The answer is 1.5. 1.5. It takes 1.5 meters. 1.5 of these is the same thing as 150 centimeters. If you cannot figure that out mentally, you would go ahead and multiply like this. 4 times 5 is 20. 4 and 1 is 4, 5, 6. That's 60. Move the decimal over 1. The answer is 6. Oops. 6. 4 times 1.5 is 6. So the area of the rectangle is 6 meters squared. Looking back up here, remember the area of a figure is the number of square units. Square units it encloses. How much is inside? How many square units? And so that's why our answer is meters squared. Now turn to the next page, please. Okay, find the area of the parallelogram. So let's see, we have area is base times height. The base is 8 meters. And notice again, the units are the same, meters, so that's good. We don't have to do anything there, convert. And then our height is, going up here, down here, that's our altitude, or what we use as our height. That is 2 meters. And 8 times 2 is 16. So the area is 16 meters squared. Okay, just a little side note. If I have 8 meters times 2 meters, and if I use, well, what property is that when I can move things around, when I commute them around? That's right, that's commutative property. So if I commute these things around, move them around, 8 times 2 is 16, and m times m is m squared. And therefore we have square meters. That's why our unit comes out to square meters. Okay, letter B. Notice that they're both in inches. That's in inches and that's in inches. Our formula is area is base times the height. So the base, that's 2.5 inches. Our height, that's 6. So 2.5 times 6. How much is 6 times 2.5? If you don't know, you could simply multiply it like this. If you can do it mentally, you'd have 2.5 6 times. This is how you should be doing it mentally. 2.5 6 times. You could add them up like this, but mentally, 2.5 and 2.5, that's 5. Right? So if that's 5, that's 5. That's 5. How much is 6 times 2.5? It's 15. Okay, so this is how you should be doing it mentally. If you can't do it that way, go ahead and multiply it out. And so my answer is 15 inches squared. Because remember, area is always squares. Okay, going down below, it says find the area of each rectangle. I noticed that this one's in meters, and this unit's in centimeters. Which one should I put it in? Well, I'm going to look down here. It says the area is blank centimeters, centimeters squared. So I need to change this into centimeters. How many centimeters is 1 meter? We went over this before. 1 meter is how many centimeters? It's 100. It takes 100 of those centimeters to make a meter. By the way, if you ever look at a ruler, one side will be in inches, and on the other side, the bottom side, that will be, or the other side will be in centimeters. And if you look closely, an inch is about 2.5 centimeters. It's kind of hard to tell in here, but it's about 2.5. Going back to our problem, this one's 100 centimeters. This side, the height of it's 10 centimeters. So we have the base is 100 centimeters, and the height of it is 10 centimeters. Okay, well, 100 times 10, that is just, add another 0. That's 1,000. So the area is 1,000 square centimeters, or centimeters squared. Number 2, find the area of each parallelogram. I only see one parallelogram. There may be a second one on yours. Not too sure. But let's see. Here's our base, and then here's our height. So that's 90-degree angle there. So base is 3, and our height is 2. So, well, 3 times 2 is 6. So it is 6 meters squared.